Hello everyone and welcome to this session. I'm Tommaso and I'm going to talk about unlocking database conversation using Semantic Kernel and Data API Builder. First of all, what do we mean when we talk about database conversation? I'm talking about a scenario in which we chat with our database. You might be familiar with scenarios in which you chat with your data. So basically, use case for the LLM when you simply upload certain documents such as PDFs to a certain location, and then you have the LLM answer to user questions based upon only the knowledge contained inside those documents. So this is called retrieval augmented generation because the LLM will have to retrieve information from the documents, from the knowledge base, and then use that knowledge to augment the way it generates the response for the user. That's why it's called retrieval augmented generation. I would like to implement something similar to that, but using the database as a data source for our information. So in this scenario, since we have a database, we need to be able to perform queries against the database using the LLM. And of course, why would you let the AI run queries against your database? Because it's a very tricky scenario because the LLM doesn't know anything about your SQL database structure, which entities it contains or whatever. And you remember, you start from a simple question coming from the user, the end user, which might be something like retrieve offerings details from a SQL database. And even if we type something like write a SQL query to retrieve offering details from a SQL database, the LLM will go ahead and straight up invent or randomly guess the way the database is structured. So you might end up adding something like what you see here on the slide. Here was talking with ChatGPT, and it randomly generated a query, which of course was nowhere near the actual data, the actual field I've got in my database. And you might say, yeah, okay, no problem. I can simply go ahead and add the database structure to the system prompt of my agent so that the LLM will actually know how the database is structured. And that's fine. Yeah, you're right. That might actually work. In this scenario, you can see that the LLM generated a query, which is actually correct. It's even using an inner join to go ahead and retrieve the details from the offering table, which contain the offering details table, which contains some details about a certain offer I made up in my database. So we are working with two different tables here. We've got the offerings, which contains the location, the period of validity of a certain offers, and it contains a foreign key for the details of that offerings. I'm figuring out I'm sort of a travel agency right now, okay? But that's not the point. But yeah, this works until you update your database. So every time you update your database and you add some entities to your database, you will have to go back to the system prompt of your agent and update that to actually use the new entities you have added to your database. That's not very good from a maintainability perspective. And you might end up having to do lots and lots of work every time you update your database, changing like relationships or tables or fields, whatever. So that's not the final way to go from my point of view. And it would be nice at this point if we had the possibility to actually expose our database as a REST API or as a modern API to better state that. And by modern API, I mean both REST API and GraphQL API. So REST API, you're very, very familiar with that. Of course, REST API, you've got all the known behavior you might expect from an API. You have GET request, POST request, put, delete, whatever. The GraphQL endpoint instead is actually a different way to perform queries using an API. So the QL stands for query language, and you're able to interrogate your API sending a query as a payload so that the API will actually perform the correct integration, will select the correct data from the source to actually return to you as a JSON. And this is what we want to use in this scenario because the LLM can very easily write GraphQL requests and retrieve the correct data, even performing join with our two different tables that we are handling right now. And the LLM can actually use an API, either a REST or a GraphQL, as we're going to see, has a plugin to actually a tool that can actually invoke to perform some action. So this is the correct way to go, but of course we still need something that will turn the database into this modern API we are talking about, and that's Data API Builder. Data API Builder is an open source project that actually takes this specific goal in mind, which is to turn the database into the modern API using either both GraphQL and REST API. It's very simple the way it works. Basically, you need to configure a JSON file that describes the database that you want to turn into an API. So you can use the CLI to do that, or you can write the JSON on your own, but you can simply have to describe all the entities inside the database and set the permissions for that entity. And then you go ahead, if you use the CLI, you will type .start on your terminal, and you will have a localhost 5000 that actually runs the server with Data API Builder inside. This is great because this is the first step we need for our database conversation scenario, okay? And these are all the supported database type that we have in DAP right now. So we've got SQL Server, Azure SQL, Cosmos DB for NoSQL, Postgres, and all the database listed here. From a perspective of security, of course, we can define tables, views, store procedures that we want to amplify, and then we can secure all the action that can be done or not done by certain roles. So we can instruct the API to understand, we can instruct Data API Builder to understand all the available roles, like reader, user, admin, whatever you might come up with as a name. And then for each role, you can define if you want them to be able to only run create, or read, or update, or delete, or execute. So you can be very specific about the way you want to implement security on your Data API, on your database APIs, basically. And you can also implement row level security so that you make sure that certain rows are not accessible to anyone. A few words about .NET Aspire. I need to add that inside this demo because when we work with Data API Builder locally, we don't only need Data API Builder, we also need a database, of course. So usually you might have your database running somewhere in the cloud or on a server, on-prem, whatever. But when you are developing your application, most of the times you might have your database running locally, such as a Docker container image maybe. So to do that, we can use .NET Aspire. .NET Aspire is a set of tools, packages, and resources that you can use to build the locally distributed application. So by distributed application, I mean application components of different components, such as, once again, the database or a Redis cache or the Data API Builder, by the way. And on top of .NET Aspire, you also have .NET Aspire integrations, which are pre-configured NuGet packages that you can use to simply add to your .NET Aspire project all the available resources that you might want to use inside your application. Everything starts from a simple .NET project called the app host, in which you have a program.cs where you build your distributed application. And then when you run everything, you will have a developer dashboard, which is very cool because in the developer dashboard, you can take a look at all the running resources inside your distributed application. You can take a look at the logs for each of that resource, and you also have metrics and traces. So let's take a step back. We are in a scenario in which we want the LLM to be able to perform queries on our database, to retrieve some data, and then generate an answer to a question based upon those data. And of course, monitoring is everything in this scenario because we might end up in a situation where the LLM go wrong and do something that we don't really figure out while we still building up our system prompt to make sure that everything works fine. And to figure everything out gets very, very difficult in a distributed scenario. So having an open telemetry endpoint with metrics and traces is fundamental for our success. So this is why I'm going to use not exactly the data API builder container resource I would be using normally, because by the way, in .NET Aspire, you have a very, very neat integration for data API builder in which you simply type add data API builder, you pass in the name of the resource, the path to the dub-config.json, and it will spin up a container with data API builder running on it. But I'm not going to be using that. I'm going to be use the executable data API builder, because locally on my machine, I've got the release candidate of data API builder, which already implements OpenTelemetry. And this is why you see that here I'm using the add executable command of .NET Aspire. I'm passing deb as the name of the resource, deb as the name of the CLI tool I want to use, the working folder in which there is the dub-config file, and the command I want to run with the CLI, which is start. So when this execute, it will run dub start on a certain folder in which there is already the dub-config.json file that will run my data API builder instance. And this is the program.cs of .NET Aspire. I am creating here the database, so the SQL Server and the SQL database itself, which I'm calling agency. And I am setting the persistency of that container so that every time I stop my application and restart, I don't have to recreate the database from scratch, seeding all the data. It's already there for me every time I rerun my application. Here I'm seeding the database, and of course here I am initiating the data API builder resource. So the data API builder is taking a few references, and this is .NET Aspire at its most. The same way you would have with a Docker Compose, you can set some references to a certain resources, saying like, I want the data API builder resource to be able to reference the SQL database resource. And the end result will be that Aspire will inject an environment variable inside data API builder containing the connection string of the database. Then I'm setting the HTTP endpoint, and I am waiting for the SQL Server. I am waiting for the SQL Server because every time dub starts, it will, first thing it will do, it will go against the database and check if the entities described in the dub-config.json are actually there. So this is why I need to wait for the SQL Server to be up and running every time. And of course, I am adding the OTLP exporter through an API here, because this will cause .NET Aspire to inject all the correct environment variables to use OpenTelemetry inside data API builder. So it will inject the endpoint, the headers containing the API keys, the protocol I need to use, which is going to be gRPC, and the name of the resource to be shown in the dashboard, which will be the same name as the resource itself. So it will be dub. And of course, I need to use that inside my dub-config.json. So let's take a look at that. This may be the first time you take a look at a dub.config.json or not, but you may find something new anyway. So you got the data source in here, which describes the actual database that data API builder is using to run in this scenario. And the connection string, as I mentioned, is a connection string, is an environment variable injected by .NET Aspire. And this is the convention .NET Aspire uses. So connection string __ name of the SQL database, which I remind you was agency. And then you've got the runtime definition in which you enable the REST or the GraphQL endpoint, or both of them. And you define some host configuration, and we've got the telemetry part. So telemetry is not new to .NET, to Data API Builder. We already had telemetry for application insights. Now we also have telemetry for OpenTelemetry. So you can enable both of them. In this case, in this scenario, I have only enabled OpenTelemetry. So enable true, and for the endpoint, I'm using the environment variable coming from .NET Aspire. Same goes for the headers, the protocol, and the service name. So every time I spin everything up, .NET Aspire will create an OpenTelemetry export, an OpenTelemetry endpoint with a certain API key, and it will inject the correct configuration that I need to use in my running instance of Data API Builder. So very, very scalable. And you also have the entities defined in here. So this is where Data API Builder gets actually configured from the database perspective. You've got the name of the entity, which is offerings in this case, and you simply identify the source. So in the database, this is going to be dbo.offerings, and it's of type table. And you can enable GraphQL and REST API for each entity. So even if you enabled REST API and GraphQL API for the entire DAB resource, you might want to exclude a certain table from a certain API type. So in this case, I have left both of them enabled, and you have the permission here. In this case, I'm using role anonymous because I'm not going to perform a request against the Data API Builder by myself. I will let the LLM do that. Of course, I could implement some sort of authentication between the agent running in a .NET Minimal API instance and Data API Builder, but for simplicity and to have like a cleaner code on the agent side, I let run it by in anonymous. And then you set up the relationship. So setting everything up from the JSON perspective can be difficult sometimes. As you can see here, you got lots of things to type. But if you take a look at the CLI bash file I wrote here, this is, by the way, what I used to actually build that the dub config JSON. It's very, very straightforward. So you simply dub init to the database, you dub add some entity, and you dub update the relationship between the entities. The only thing I had to add manually is the telemetry thing. So I didn't use the CLI to do that because I wanted to show you only right here. But you can, once again, always use the CLI to configure your dub config JSON from every point of view. So once we had that and we run everything, we end up in a situation like this. We will take a look at the front end and the API later on in another demo. But right now we want to be focused on the dub executable resource, which, of course, if we take a look at here in the details, we can see all the different environment variable injected. So the connection string agency coming from the SQL Server and SQL database we've got here. We've got the OpenTelemetry endpoint, the headers with a key, and everything that we need to actually run Data API Builder in our scenario. We can go ahead and take a look at the logs for this instance. And we can, of course, navigate to the endpoint, which is localhost random port assigned. And we can either go in the Swagger endpoint, and of course, we can also hit the correct endpoint, which is /API/name of the offerings, but having Swagger is better here. So you can take the offerings, try it out, and execute the query, and you've got all your data back. And you can also use filters using OData expression when you perform this query. So you can filter out your data using REST API. Pretty cool, super useful. But we're going to be focused on GraphQL here. So in the GraphQL endpoint, so localhost random port /GraphQL, we've got the way we can build, we can see the way we can build a GraphQL request for our endpoint. So in this case, I'm running a query. So I'm querying data, I'm getting the offerings, all the items inside the offerings entity, and I'm only retrieving location valid from and valid to. And I am also retrieving the description, which can be found inside the offering details entity. And if you're not very familiar with how you can construct a query for GraphQL, you can use the query builder on the left here that will actually help you like adding or removing field from your query. And this is for testing purposes only. This is not what you will have exposed to the final user, but you can always come here and test if everything is working correctly. You can run your query and see that everything is doing as expected. So this is fine because we got our first objective achieved thanks to Data API Builder. So basically we got our database and it is exposed as a modern API, REST endpoint, GraphQL endpoint. Lovely. Then we need to take the next step, which is add some LLM to our scenario. And to do that, I'm going to use Semantic Kernel. So Semantic Kernel is an orchestrator is open source. So it's it's an orchestrator for the for agents and for the AI workflows. So using Semantic Kernel, you can create an agent, which is basically a system prompt and some plugins combined into a single entity that can use an LLM in the background to perform some action. And it supports both OpenAI and Azure OpenAI, and of course also Oyama and Hugging Face. And third, but not least, it's also available in C#, Python, and Java. This is very, very important because when you build an agent or an AI workflow, most of the times you might end up having to cooperate with your data scientist friends, and they, of course, prefer to write code in Python. And if you can work on Semantic Kernel, them in Python, you in .NET, it will be easier to cooperate from a code perspective, taking their work and bringing it inside your .NET application. Okay, so this is a very, very important feature from my point of view. So we're using Semantic Kernel, we are building an agent, and we are giving it a plugin, which is going to be Data API Builder. So Data API Builder will become a plugin for our agent. Let's see how that's actually implemented inside our code. This is the .NET Minimal API, a single endpoint, a post endpoint, API chat stream, and it handles the chat history with the LLM, and it handles their incoming requests using streaming. Nothing special here, but the actual agents, it's what I want you to focus on. So in here, I am creating a Semantic Kernel agent. I am giving it some instruction taken from a TXT file, and I am setting the prompt execution settings, like the tool call behavior. I want Semantic Kernel to be able to automatically invoke all the plugins that the LLMs will tell him to. So the way it works, the Semantic Kernel agent will ask the LLM, will send the LLM a payload saying, this is the answer, the question of the user, this is my system prompt, and these are my tools available. What do I need to do? And the LLM will go ahead and say, here's the tool you need to run to answer that question. And Semantic Kernel can actually auto-execute locally that tool, which is going to be, of course, an HTTP request towards Data API Builder in our scenario. And I am importing the plugin for Data API Builder using OpenAPI. So I'm importing the plugin from OpenAPI, but here's a slight twist because I'm not really using the REST API of Data API Builder. I'm using the GraphQL endpoint. I can only import plugin from OpenAPI in Semantic Kernel. So I'm doing something strange here. I am creating a fake OpenAPI descriptor for the GraphQL endpoint. So I'm using a placeholder for the server. I'm saying that there's a path called GraphQL that accepts post request, and it's a GraphQL endpoint. And in the instruction of the agent, I'm saying, okay, to access the data, you must use that post tool. And the that post tool is a GraphQL endpoint. Do not guess any type of schema, relations, or data types, whatever. You always use introspection to understand the whole schema. This is cool about GraphQL because you can always ask a GraphQL endpoint to expose its own schema so that you can figure out what's inside, what you can do and what you can't do with all the entities it contains. And in this case, I'm letting the LLM do that so that the LLM all the time can actually figure out what's the schema of the GraphQL endpoint. And this serves our purpose because if I update the database, I only have to update the dub-config JSON. GraphQL will auto-reload with a new dub-config JSON on the server side, and the LLM all the time will have the updated schema of GraphQL and will always be up to date with the new updates made on the database. So I don't have to change the system prompt, never, once I wrote it for the first time. And once I do that, of course, I can simply invoke the streaming async chat with the agent to get the answer from the LLM. But let's see that in action because it's way better. So I've got my front end. I can go ahead and navigate to the front end. Let me take my, okay. This is a predefined prompt, like, are there any offers for London? Let's set the streaming chat and send the request. And now we can take a look from the trace perspective of what's happening here. So the API is getting the request from my front end with the question of the user, which is, are there any offerings for London? And it's sending it to the LLM. And this is what the LLM gets. So the row, the content, and the question of the user. And the LLM will go ahead and say, okay, to do that, you need to invoke you need to call a certain tool, which is called apppost. And you need to run this query. This is the query that you can use to actually use introspection against a GraphQL endpoint. So first thing you want to do, call GraphQL endpoint using introspection. And then my local API will go ahead and call data API builder in the GraphQL endpoint, performing the introspection. Getting the schema, we'll get back to the LLM, and let's visualize that. It will send in the actual schema retrieved from the GraphQL endpoint, and the LLM will say, okay, based upon that, this is the query you need to run to retrieve all the offerings with the related details using that GraphQL endpoint. And of course, my API will go ahead and call data API builder to do that. And once again, I am not doing the call manually, but it's semantic kernel. Semantic kernel is the agent that is performing the query against data API builder because I've set the tool call behavior as auto invoke. And last but not least, once again, my API will get back to the LLM, passing in the data retrieved from the GraphQL endpoint, and the LLM will generate the answer, the pretty answer to show to the user, which is this one. So if you go back to the front end, we can see that I found 2 offerings for London. This is the first, this is the second. Feel free to ask more questions. So this is super nice because, first of all, we've got a solid scenario in which we can talk with our database and we can take a look and see what's happening behind under the hood. So if something gets wrong, we can always come back here and take a look at what's happening. Like if I get a wrong call against data API builder, I can always go ahead and say, okay, what did the LLM tell semantic kernel it should run as a query? So I can go ahead and debug that and maybe adjust my prompt like I did many times while I built this demo. And of course, you always have the metrics that you can go ahead, take a look at the metrics. You can see that you've got certain request duration, so you can see how long it took for data API builder to answer back because you have open telemetry. And this is a great way to debug such a scenario in your local machine. So that's all. So thank you for your time. I am leaving you some resources starting from Data API Builder, .NET Aspire, and Semantic Kernel. So the 3 main tools we've seen today. So you can deep dive into the documentation for each one of those. I'm also leaving you a blog post I wrote about this explicit scenario on Dev2. And I also, of course, sending you the GitHub repository for my code. So you can go ahead, take a look around, and see how things were implemented if you need to take a double look at that. Before I leave you, let me remind you that we've got a new learning path, which is called Develop Data-Driven Application by using Microsoft Azure SQL Database. So please go ahead and take a look at that. Very interesting. That being said, thank you so much for your time. Hope you like it, and see you in the next one.